Video, what I'll show you is how to make a tone generator by using an Arduino and a headphone jack. So the setup is like this. I've powered the Arduino using the USB and I've connected the output from pin 7 to the mic of the headphone jack. That's all this is setup. So for the tone generator we will be giving input from the computer and that would determine the tone that is being played. So this is the experimental or the experimental setup of this tone generator. Let's move to the computer. So this is the script. This is the script of the Arduino that I'm currently using for the tone generator. The main part of the program is this. Now this serial.available it just waits for some serial data to be sent by the user through the serial port, and once it recognizes that something has been sent, it just reads the data and then sets the value for C. Now C, a better value would have been F, but C is that's a frequency value. So if you know anything about the tone module that is already there on, it takes in the value for the pin and then the frequency and then the milliseconds that this tone has to be played. So what that does is it takes the user input and plays the tone, like it loops the tone until the user sort of gives you another tone to play. So suppose you have 100 Hz that is playing, it'll keep on playing 100 Hz until the user decides to change it to some other value. So we will be using low frequency tones for this, so that you'll be able to hear it better. So this is the program that has been burned to the Arduino. And how does a user send serial data, you're asking? So you open the Python console and then open the serial port. In my case it is TTY-ACM1 and at the same 9600 baud rate. And now in order to give an input to the Arduino, you just write serial.write and you pack the data, pack the number that you're sending as a binary. Now before we get into the audio part of it, I want you to sort of see what the Arduino is sort of sending. So if you send this from the computer, you can see that it immediately sort of prints 100 on the serial monitor. So that means it has recognized that as 100. So that's the crux of it. So now let's listen to the audio. That's 100 Hz. Now if I want to change it to some other value, let's say 120, I just need to do the same command and just change the value that I'm giving there. Bam, that's all. It's really that simple. Okay, I just paused in to open up the FFT app, and you can see that this is printing out 119.95. It's just 120 Hz, so it is giving out a 120 Hz. Now say you want to change it, you want to go to 80, and if you sort of want to set that, just click on that and then bam, changed 80 Hz. Now 90, if you want to give 90, just go change this value. The FFT goes a little bit haywire, but okay. So that's the idea. I mean, you can sort of like give any value to the input, any value as input, and the output will be a square wave of that particular frequency. It's a really neat thing to do, but I mean, considering that you can only do square waves, it's a little bit of a disadvantage. But then this thing is powerful. This methodology of just giving input via the user giving input via the serial port is something really interesting, and that's about it. Bye.